All right, we are in Algebra 1. Today's lesson is 9-3, Multiply Binomials. In terms of the unit guide, we are right here, which means on Monday when we get back, we're going to be multiplying difference of squares, and then we have a quiz on Tuesday. All right, so today's date is Friday, March 6, 2020. Our objective today, I didn't pass out the cards, but we'll go fast and furious here. Kira is to
multiply a binomial by a binomial.
There it is. And by, again, can someone tell me what by means when you hear that word, Ugo?
It's just like only one of the things.
Not quite. So if I had a monomial, that would be one. What about by, though? If I think of like a tricycle or a bicycle, what do you think by means, Ugo?
Me?
Yeah, you want to try it again? Or you can call in someone else, too.
It's like when two of them are together.
Two, yeah, exactly. So by means two. And then nomial means two numbers. Okay, so a binomial by a binomial. And here's our rule that we talked about yesterday. If I have a coefficient times x to the power of n and a coefficient times x to the power of m, the bases are the same. I say have the same x and same x. What is this equal to? What is this rule? And Eamon, if you could close your laptop for me too, please. What is this rule? Who has this? And if you don't know, look back at 9-2. What do you do with the coefficients? What do you do with the exponents? I have one hand, but she has her fictional card turned in. Esha, yeah, go for it.
I think it's a, b, x, and then n plus m on the top.
There it is. Everyone write it down. It's a, b, and I don't have to put these little dots, but I'm just saying all three of these things are being multiplied together. The a, the b, and then finally the base x to the power of m plus n. Yeah, Larissa.
Since there's two x's, what do you just ignore it?
So if you ever have the same base, and this is going back 2 units, whenever I have the same base, I add their exponents. So for example, if I had 2 to the power of 2 times 2 to the power of 3, this is equal to 2 to the power of 2 plus 3, which is 5. And you can check this also, like 4 times 8 should be 32, and 2 to the power of 5 is 32. Yeah, good question. And then let's write this word. I think this was Hazi's rule, right? Let's write Hazi's rule in words. So when I multiply polynomials, I do what to the coefficients and I do what with the exponents. What operation do I do? Again, this is just taken, copy-pasted from last time. Ugo already has his card in. Kira already has her card in. I need to hear from, I guess it needs to be Larissa or oh yeah, you did the warm-up, but yeah, go for it again. Eamon.
You multiply the coefficients and add the exponents.
Yes, everyone write it down. So these coefficients a and b were multiplied, and these exponents n and m were added. Perfect. All right, so I'm going to show you how Mr. Sindel does most of my multiplication in my head. If it sounds like I'm really, really quick at doing mental math with bigger numbers, it's because I'm using tricks. And here's one of the many tricks that you can use when you're multiplying. If I see 23 times 13, and you might have seen this before because it's more of like the Common Core state standards now, I think of this as 20 plus 3 times 10 plus 3. Can you guys agree that the things in the parentheses are being multiplied? So I just, this thing times this thing, and this left thing that I multiplied by 20 plus 3 is 23. These things are exactly the same thing. Can you see that this line holds true? This left side and the right side must be equal. They look exactly the same. I'm just adding some addition on the right-hand side. So what I'm going to do here is I'm going to have this cool little tool, and you can totally do this in your head. This is just to set you guys up. And I'm going to say, and it doesn't matter which one goes where. I'm just going to randomly say, I'm going to do 20 plus 3 on the top. So I'll do plus in between 3. I could have done 20 plus 3 on the left. It doesn't matter where it goes. I'm going to do 10 plus 3 on the left, so 10 plus 3. And by the way, I really want to make this clear because I've made this mistake before. Don't put this sign in the middle for this one. Always put the sign in front of the number. So if you put the plus right there, just move it down here. Because otherwise it'll mess you up. If there's a negative, you'll forget to distribute the negative if you put it up above here. All right, so what I'm going to do, I'm going to use this tool and I'm going to multiply. I'm going to say 10 times whatever's here, 10 times 20 for that little cell right there. And 10 times 20 is what? Lots of quiet raised hands are going to get in here. Kira. 200. What about this cell on the top right? What do I multiply and what is the answer? Right here where this dot goes. What is this going to be? Yeah, Larissa.
It's going to be 30.
It is indeed going to be 30. What about in the bottom left? I'm going to have what? Oh, question, yes.
What did you multiply 3 by?
So I did 3 times 10. So these original cells from the white.
Oh, I see.
Yeah. Good question, good question. Ulysses, yeah, 20 and what? Yeah, 60. And then finally in the bottom right, Ugo, I have 9. All right, so everyone's seeing that we're multiplying to get this, and then I'm going to now add all of this together. So I multiplied these sides, and then once I get the inside here, I just add all of that gray area. So now we add. So I'm going to say this is going to be equal to 200 plus 30 plus 60 plus 9. And notice that it's kind of easy now because it's by place. Aside from these two middle numbers, the two middle numbers, I actually have to do some addition, but 200, 3 plus 6 is 9, 299. The answer here is 299. 299. And if you want to check that, I can pull up my Spotlight search and do 23 times 13, and oh, look, it's 299.
Oh.
It's just a cool way of doing math.
So that's all we have to do in this con?
Well, now we're going to apply it to polynomials. So if you ever learn a trick for a polynomial, that generally is going to be a trick that works for numbers. And I have been learning more and more about this past year, so I'm really excited to share what I've learned this past year with you guys, and I haven't been able to share that with other classes before. So when I teach you a difference of squares, I'll teach you what that really means when I'm talking about just numbers. Because everything that applies to polynomials also applies to numbers. So here's the trick for numbers, and now we're going to do the reverse of that. We're going to apply it to polynomials. But first, let me talk about the first method of multiplying binomials is called FOIL. It's actually doing something different than what I just showed you. There are two common methods that are taught throughout the world. One is FOIL and one is using the area model. More typically, modern nations are trying to do the area model because it's something that you can do in your head easier, and it's just kind of more, you can go backwards easier too. It sets up for a lot of nice things, but the old-fashioned way of teaching it, in my opinion, is FOIL. What is FOIL, Mr. Snell? Has anyone ever heard of FOIL before? No? FOIL, oh, you have? Ooh.
I forget what it stands for, but I feel like I've definitely heard that.
FOIL stands for the order in which you're going to multiply. I'm going to multiply the firsts. What does that mean? Well, I'm multiplying this 2x, which is the first, by 3x, the two first ones. So 2x times 3x. And then again, I have to use my rule up here that says I'm going to multiply the coefficients and then add the exponents. Do you remember the rest of it? Oh yeah, go for it.
No, I was just asking, isn't this kind of similar to doing like y1 minus y2? Kind of
not-
just in the way of splitting up the parentheses.
Not really.
Okay.
Unless there's a connection there that I'm missing, which I might be doing. I don't know. So there might be a connection. I just haven't thought about it before. So I'm going to multiply the 2x by the 3x. And now we have to do the review from yesterday. What is 2x times 3x? Yeah, let's go with, I was going to call you the wrong name. Ulysses, sorry.
Is it 6x?
6x, and then how many? This was x to the power of 1, x to the power of 1. I'm going to add those, and I get,
6x to the second.
yes, 6x to the second, 6x squared. Okay, so that was the first. Then the O stands for outer, which means the outmost. So I have 2x and 4. So 2x times 4 with another quiet raised hand. What is 2x times 4? Asha?
2x times 4 is 8x.
And it's a positive 8x, so I'm going to do plus 8x. If it was a negative 8x, I would do minus 8x. And then I stands for inner. Inner means I'm going to do the two inside things. I have a negative 1 and a 3x. Again, I'm including the sign that comes before. So negative 1, not just 1, but negative 1 times 3x. And what is negative 1 times 3x? Kira?
Negative 3x.
Negative 3x. And we're almost done. I'm on to L, which stands for last. The last two numbers, this negative 1 and this positive 4. Negative 1 times positive 4 is what with a quiet raised hand? Ugo? Negative 4.
It's really easy to get these wrong.
Yes, it is.
Yeah.
So usually this symbolic way of showing FOIL, first, outer, inner, last, looks like this. First, and I do a little arc. Outer, and I do those. Everyone sees first and outer. And then inner, I'm going to go on the bottom. These are the two inner ones, and last. So if you ever see this symbol, what I'm doing here is I'm foiling. I am doing the first, outer, inner, last to multiply them together. The reason that we teach this is, I don't know, it's faster. This is the method that if you want to take the SAT and get a high score, you need to learn how to FOIL. It's the fastest way of doing it, but it breaks down when I do like a trinomial times a quadnomial. You're like, oh my God, my head's gonna explode. That's where method 2 comes in, and method 2 is versatile. I can apply it to any problem. FOIL purely only works when I do a binomial by a binomial, 2 terms times 2 terms. If I do 2 terms times 3 terms, you can adapt FOIL. You don't spell it FOIL anymore, but it's kind of the same procedure. What I'm really doing here is distributing. So if I kind of ignore this -1, I distributed this 2x with 3x plus 4. And now if I ignore the 2x, I'm really distributing the -1 with 3x plus 4. So it's kind of like distributing twice. That's why I call it advanced distribution. Advanced distributing. Yeah, Larissa.
Does it matter your like where you put the numbers, like your
The order in which you write them?
yeah.
No. This is the right answer. There's something that's called standard form that I have not gone over, and maybe I should, but I don't think I have enough time today because it's a Friday. So we're almost done. We're actually not done because we can simplify. Remember, every single time that you have things that are being added or subtracted, we need to combine like terms. So the question is, are there like terms? There must be if Mr. Sindel said that we can simplify, right? So what are the like terms? Yeah, Esha.
8x, or positive 8x and negative 3x.
There it is. Can you combine everything into one brand new equation? Or new
6x to the
expression.
power of 2, plus, what would 8 plus negative 3 be?
So it's 8 minus 3.
Oh, 8 minus 3. Okay, 5x minus 4.
There it is. Done. And box it. You have now multiplied your first binomial, or maybe you've seen it before and you've reviewed how to do a binomial. I will give you a heads up, and I don't mean to spring this on you early, but yes, it's awesome that we know how to multiply these. The next unit, so not for a while, we're going backwards. I'm going to give you 6x squared plus 5x minus 4, and you will give me back 2x minus 1 times 3x plus 4.
Oh,
So-
that sounds hard.
If you want to be thinking about ahead, how would you go backwards? And you could, of course, just look it up. It's really cool if you invent your own math to figure out how to go backwards. All right, so I'm going to show you the more versatile method, the box method. And sometimes I call this the area method. It has many names because there's no agreed upon name. So it's the area method, it's the box method. Sometimes it's called the tabular method because it's a table. So table in terms of an adjective is tabular. Tabular. If we were doing purely Eureka math, it would be called the tabular method. And I don't stick to any one name, so I'm sorry, I'm going to be using all those. I just like to switch it up. I'll try to use the box method because that's what I wrote here, though. All right, so the box method states the same thing that I did up here. One binomial goes on one side of the box. So I'm just going to randomly say, wait, where's our binomial? There it is. I'm going to randomly say 2x minus 1 is going to go on the top. It could have been on the left. 2x minus 1 on the top, and then that means 3x plus 4 is going to go on the left. 3x plus 4. And then I'm going to find my values when I multiply my column times my row. So for example, this cell right here is going to be 2x times 3x. So let's zoom in here now that we know what we're doing. What is 2x times 3x to get this value of the cell? Oop. If I do shift spacebar, it goes back. Okay. Sorry, Ashley, you've been participating a lot. I want to get some more. Yeah, Eamon.
Oh no, I was.
Oh, you're doing math. Yeah, Larissa.
It would be 6x. You want me to keep going?
6x. So this is power of 1, power of 1.
Squared.
Squared. Yeah, perfect. Thank you. Top right. I have -1 times 3x to get this cell right here. What is -1 times 3x, Kira?
Negative 3x.
Negative 3x, all right. Asha, you can participate again. You've cooled off a little bit. 2x and 4 in that bottom left. Ulysses, yeah.
8x.
8x. Perfect. And in the bottom right, I have... Asha again.
Well, 4 plus 1 is 5.
Ooh, careful. It's always multiplication.
Oh, sorry. 4.
Careful. -1 times 4 is...
Oh, I need to, okay. Negative 4.
There it is, yeah. Thank you. -4.
I didn't erase my negative 2. I mean, my yeah.
All right. So when we do this... Oh, question, yes.
So why did we get? So I guess if the
So the 4 doesn't have an x on it, so should we just assume that it doesn't have a 1 exponent?
Yes, so there's no 1 exponent. You can think of this as x to the power of 0 if you like, which is 1.
Okay.
And 1 times anything is -4.
So that's why we just get 8x instead of 8x squared.
Yeah, exactly. So you can think of that, this 4 right here, yeah, sorry, as x to the power of 0. So x to the power of 1 times x to the power of 0, I add 0 and 1, and I get 1.
Okay.
Yeah. All right. And then, does anyone see kind of a relationship between what's happening already? Oh, a 6x squared. Oh, look, a 6x squared. Oh, look, an 8x. Oh, look, an 8x. Oh, a -3x, a -3x, and a -4. It matches up perfectly so far. So we basically have the same problem that we had before. But now, what we can do is I can add on another column right here. And I can say 2x minus 1 minus 7x squared. I can add on another column. And I can say plus 3x. I can add on another row and say minus 7x to the power of 8 and add on another row. This can go endless. I don't have to do a binomial by a binomial. I can do a trinomial times a quadnomial. It doesn't matter what I do now. But yeah, for now it does turn into the same problem. So we're going to basically rewrite the same stuff. We're going to add all of this area up. So I'm going to add the 6x squared and all these terms. I'm just going to write it out here. So I'm going to say 6x squared. Ooh, I want to show you guys a shortcut right now, because you guys can already see the relationship between the two. They're going to be equal, right? Here's the shortcut. As long as these are binomials, and they're called linear binomials, but we haven't gone through that yet, these two will always be like terms. So go ahead and draw this little diagonal dash. This -3x and this 8x should always be like terms if it is linear binomials, which I believe all of today's lesson is going to be. So this only applies to today, and it doesn't always happen, but try to pay attention to those diagonals because they generally will be like terms. So you can just skip a step and say, oh, instead of writing it all out, I can just add those right now, and 8x minus 3x is 5x. And then, of course, writing out the -4, and we have our answer. So again, to get that, we added the gray area. Add the gray area. Is it gray area? Yeah. I have a family member that's spelled Gray, so I always think that gray is spelled that way too. Add the gray area. All right. Any questions up to this point? I've taught you everything that you need to know, and now we just need to practice it. I will say this also, for today's lesson, you can choose whichever method that you want. I highly recommend being proficient at both the FOIL method and the box method, because the FOIL method, if you ever plan on taking the SAT, will come in handy. For my class, I highly recommend the box method because we are going to be doing bigger things later. Maybe not in Algebra 1, but definitely in Algebra 2 and pre-calculus, where I'm going to do big numbers, like a trinomial and stuff like that. And the box method is great at doing that. By the way, when we go backwards also, we're going to be using the box method. I'm not going to do reverse FOIL or anything. All right, so example 1. What method do people want to use? Kira, what do you want to do?
FOIL.
Let's do FOIL. All right, so first, go Kira.
X times -7x, I think it's just -7x.
Ooh, careful, -7x.
Power 2.
Good, -7x squared, and then I do that one.
Should I keep going?
We'll give it to someone new. Yeah, Ulysses.
And then you do x times 3, which would be 3x.
3x plus 3x. Next, what do we do? Ugo.
-2 and -7.
Yep, and that is
Positive 17x.
positive, ooh, careful, positive, not 17x, but positive,
Oh wait, 14.
yeah, 14x.
Good.
You're good. And then finally, Ulysses again.
Which is -2 times 3 is -6.
-6, perfect. And then the last thing that we need to do is we need to do something. Ulysses has an answer, but you just did 3 in the last 4 participations, so I'm going to give it to Esha.
We need to find the like terms, and positive 3x and positive 14x are the like terms. So you want me to keep going?
Yes, can you please write our final answer?
So we have -7x to the power of 2 plus 17x minus 6.
Oh, is that why, Ugo, did you say 17? Oh man, you're skipping a step, nice. Good job, Ugo. There's our final answer. Cool, so we've done one together. You guys can do example 2 and 3 on your own. I want to definitely talk about example number 3 and 4 because 3, something interesting happens. Like if I have something that looks almost exactly the same, but there's just a difference in terms of a plus or a minus, special things are going to happen, and you'll see what happens when you do the math. And then everyone right now, can we all write down, for example, number 4? Whenever I have anything squared, I have 2 of those things. So off to the side here, underneath example 4, please write down the following notes. If I have something that says like 2 squared, what I really have is 2 times 2. Which means if I have the quantity of a minus 6 squared, I really am saying what is a minus 6 times the quantity of a minus 6. Oh shoot, I forgot to do lunch. For number 2, I'm going to do the box method so we get some variety in our practice. The quickest way to make a box is you make a box or rectangle, and then you just make a line that comes up through the top, a line that comes out through the left. And let's label this thing. So I have an 8y minus 4 and a 9y plus 5. On the inside of the box, 8 times 9 is 72, and then y to the power of 1, y to the power of 1 adds to, or I guess they multiply, and I add the exponents to get 2. I get a negative 4 times 9 is negative 36y. 8 times 5 is 40, and then I also have a y, and negative 4 times 5 is 20. So adding up all of those green, notice that these diagonals are like terms again, so this is going to be 72y squared plus 4y plus 20. And there's our final answer, box it. Example 3 is going to be interesting again because these are opposites. So there's an actual term for this, and I'll write it down. These things are called conjugate pairs. Conjugates. Conjugate just means you flip the sign in between, and since there's 2 of them, it's a pair. And usually there's always going to be 2 unless there's some other third sign that you can add, right? So these are conjugate pairs. What's going to happen? Let's go back to using FOIL, and then I'll come back to use the box method in the final one. So foiling first is n times n. Again, these are n to the power of 1, n to the power of 1. So n times n is n squared. Outer is negative 4n. Inner, positive 4n. And last, 4 times negative 4 is negative 16. And the cool thing that happens here is, what is negative 4 plus 4, are like terms whenever we FOIL will always be in the middle. Negative 4 plus 4, well, 4 minus 4 is 0, so I have 0n. So you could write down 0n, but 0 times anything is 0, so it's just 0, and you might not even, you shouldn't even write that, right, to simplify it. So I'll have n squared minus 16. And the cool pattern, whenever you have a conjugate pair, you will never have a middle term. The middle term is 0. All right, and then what happens here if I square the same thing? So it's not even conjugate pairs. I didn't even switch the sign. It's the same sign. Again, we write it like this. Let's use our box model. I was about to call it the tabular model. So I make my rectangle, I divide it up that way, divide it up that way. I have an a, let's change colors here. I have an a minus 6 and then a minus 6. A times a, that's a to the power of 1, right? A to the power of 1. A times a is a squared. This is negative 6a, negative 6a, and negative times negative is a positive 36. Again, these diagonals are going to be our like terms, so my final answer is a squared minus 12, because a negative 6 and another negative 6 is negative 12a, plus 36. So it seems like that's just a normal answer, but when you do lots and lots of these, I'll point out a pattern now to help us. By the way, this is our final answer, and we're basically done with the notes. One final pattern before I leave you. These numbers are always going to be very unique. That number right there is always going to be a perfect square. Specifically, I'll just write square. That's always going to be a perfect square, and what squared is it? 6. And it's always going to be positive. So those signs, it's always going to be a positive square. Sorry, a positive square. And this number right here, let's do, sure, yellow. This number right here is always going to be 2 times whatever this number is. So if this number was 4, it would be 8, positive 8. If this number was negative 3, it would be negative 6. It's always 2 times whatever the last. And that will always, always happen. And we can actually prove that later. But there's the pattern that I'll point out. You can try another one. Try like, I don't know, x minus 7 squared and see what happens. Well, x minus 7 squared, I should have an x squared. I should have negative 14x, and then I should have the square of that plus 49. All right, so that concludes our notes 9-3. Good luck on the homework.